So now that we've finished covering our definitions of our trigonometric functions, our 6 trigonometric functions using right triangle trigonometry, let's put those definitions to use to help us in solving some word problems. A 20-meter line is used to tether a helium-filled balloon to the ground. Because of a breeze, the line makes an angle of 85 degrees with the ground. What is the approximate height of the balloon? Round to one decimal place. Well, as with any word problem, it's always a good idea to draw a picture if possible. All right, so here I have my balloon and it's attached to the ground. We know that the length of the line used to tether the balloon to the ground is 20 meters, and we know that the angle between our line and the ground is 85 degrees. What are we trying to approximate? The height of the balloon off the ground. And notice that drawing in this height here, we have generated a right triangle. Okay, here we have a right triangle. Now, again, this drawing not drawn to scale, but it should give you a good idea of what we are trying to find. So, looking at this right triangle, we have this angle, and with respect to the given angle of 85 degrees, we are trying to work with our opposite side and our hypotenuse. Opposite and hypotenuse. Now, is there a trig function that relates our opposite sides and our hypotenuse of our right triangle? Yes. The answer, sine. Think about our sine function. We know that the sine of theta, the sine of our angle theta, has to equal the ratio of our opposite side divided by our hypotenuse. So what does this mean? Plugging in, the sine of 85 degrees has to equal h divided by 20. And now we can solve this equation for h by multiplying both sides of the equation by 20. H is equal to 20 times the sine of 85 degrees. And taking out our calculator and plugging this into our calculator, 20 times the sine of 85 degrees gives us approximately 19.9 meters. One thing, when you guys go to plug this into your calculator must be in degree mode, okay? If we are doing trig and measuring angles in degrees, like we are in this section of the chapter, make sure it is in degree mode. Otherwise, you will not get the correct answer. Let's look at another one. You are standing 45 meters from the base of the Empire State Building. You estimate the angle of elevation to the top of the 86th floor of the observatory is 82 degrees. If the total height of the building is another 123 feet above the 86th floor, what is the approximate height of the building? Round to one decimal place. All right, so again, always want to start off by drawing a picture. Here we are, we're standing down here on the ground, okay, up to the 86th floor where our observatory is. We are 45 meters from the Empire State Building. That would be the bottom portion of this right triangle here that we have generated. And we also know that the angle of elevation is from the horizontal up to whatever we are looking at is 82 degrees. And we know that the building is 123 meters taller than our 86th floor. All right, so here we have a good drawing of what we are trying to find. We now need to approximate the height. Well, do you guys agree that if we need to approximate the entire height, that would require us to find this side of our right triangle? Okay, so whenever you're trying to find something, if it's an unknown, give it a variable label. Let's call it x. Okay, we must determine the length of the side opposite the 82 degree angle. Let's label that side as being x. So, with respect to our 82 degree angle, we are trying to find the opposite side of our right triangle, and we are given the adjacent side. Is there a trig function that relates opposite and adjacent sides of right triangles? Yes, that would be the tangent of theta. Tangent of theta is equal to opposite divided by adjacent. TOA. This means that the tangent of 82 degrees is equal to x divided by 45, opposite over adjacent. And to solve for x in this equation, we would multiply both sides by 45. X is equal to 45 times the tangent of 82 degrees, giving us x is approximately 320.2 meters. So that's this distance right over here. Well, if this is approximately 320.2, how would we approximate the total height? We would need to add 123 meters, giving us 443.2 meters as the approximate height of the Empire State Building. Okay, all right, so we've got our total height now. Now, one of your friends is on the 86th floor. Approximate the distance between you and your friend. Round to one decimal place. So you're down here, your friend is up here on the 86th floor. That means we need to find the hypotenuse of our right triangle. So again, anytime we're trying to find something, give it a variable letter. Call it, in this case, we'll call our hypotenuse D, representing the distance between you and your friend. Well, always best to use the given information, right? Given information is always correct. So with respect to this 82-degree angle and this 45-meter side, this is the adjacent side and our hypotenuse. Is there a trig function that relates adjacent and hypotenuse? Yes. That would be cosine. Remember that the cosine of theta is equal to adjacent divided by hypotenuse, the ratio of the adjacent side divided by the hypotenuse. This means that the cosine of 82 degrees is equal to 45 divided by d. And to solve for d, we would multiply both sides of the equation by d. That would give me d times the cosine of 82 degrees is equal to 45, and then divide by the cosine of 82, giving us d is equal to 45 over the cosine of 82 degrees. Plugging that into our calculator gives us the distance d between you and your friend is approximately 323.3 meters. All right, one more example here. All right, this one's a little bit tricky. I like this one. Good challenge. In traveling across flat land, you notice a mountain directly in front of you. The angle of elevation to the peak is 3.5 degrees. After you drive 13 miles closer to the mountain, the angle of elevation to the peak is 9 degrees. Approximate the height of the mountain and round to 2 decimal places. Okay, so here is our image. Notice if we start out here, we're driving. We have an angle of elevation of 3.5 degrees. We drive 13 miles closer to the mountain. Our angle of elevation is now 9 degrees. And we want to approximate the height of our mountain, okay? And so if we take a look at this, how many right triangles are we dealing with? Remember, this whole section is about right triangle trigonometry. Well, I've got a small right triangle here, okay? And then I also have this larger right triangle with this 3.5 degree angle, okay? So we are going to want to use those two right triangles to help us. Now, we can't really come up with our trig relationships because I only have one piece of this bottom side of our big right triangle. I only know that this distance is 13. But if we want to use this bottom side of our right triangle, we can label an unknown component, right? You can always give unknown some sort of variable name. So let's call this distance x. All right? So let's see if we can't come up with a couple different relationships here. Notice, with respect to this 3.5 degree angle, okay, we are trying to find the opposite side of the right triangle, and we have some information about the adjacent side. Is there a trig function that relates opposite and adjacent sides of right triangles? Yes. Remember, tangent of theta is equal to opposite over adjacent. So in this case, we would have the tangent of 3.5 degrees is equal to h divided by 13 plus x. Yes, this whole bottom side of the larger right triangle would be 13 plus x. So we just set up an equation here, and we have two variables. There are two unknowns. If we have two variables or two unknowns, we will need at least two equations in order to solve. So let's see if we can't come up with another equation using this smaller right triangle. Now, again, we have an angle, and with respect to that angle, we want to find the opposite side, and we have our adjacent side as being x. That means that the tangent of 9 degrees is equal to h divided by x. So here we have two equations and two unknowns. What we have just done is created a system of equations. And how do we solve a system of equations? Using substitution, all right? We are going to use substitution to solve this system of equations. All right, so let's get rid of our picture here, clean this up because we're going to need some room to do some work. All right, so at the end of the day, our goal is to approximate the height. Yes? All right, we are trying to find h. So one tip is that whatever you are trying to find, if possible, isolate the other variable first. Okay, when doing substitution, isolate the other variable of what you are going to find. So instead of isolating h to start off with, let's try to isolate x. And it's going to be easiest to isolate x in this equation here. Notice I could isolate x by multiplying both sides by x and dividing both sides by tangent of 9 degrees. X is equal to h divided by the tangent of 9 degrees. Next, we need to now substitute that quantity in for x into our other equation. That gives us the tangent of 3.5 degrees is equal to h divided by 13 plus h over the tangent of 9 degrees. All right, so we're trying to solve for h. In this case, we have h's in a denominator of our fraction. We want to get it out of the denominator by multiplying it over to the other side of the equation. All right, multiplying 13 plus h over tangent 9 degrees by tangent 3.5 degrees, if I distribute, that gives me 13 times the tangent of 3.5 plus the tangent of 3.5 over the tangent of 9 degrees times h. And all of that is going to be equal to h. So notice that we have multiple h's in this equation. Right? If we have multiple h's, we want to group all of our h's on one side. That way we can try to combine like terms or factor, right? Combine all of our h's on one side of the equation. So let's subtract this quantity from both sides of our equation. This gives us 13 times the tangent of 3.5 degrees is equal to h minus the tangent of 3.5 degrees divided by the tangent of 9 degrees times h. Well, now, because this h is common to each of these terms on the right-hand side, I can actually factor out an h from each one. This gives me 13 times the tangent of 3.5 degrees is equal to h times 1 minus the tangent of 3.5 divided by the tangent of 9 degrees. And finally, to solve for h, because these are connected by multiplication, to undo that multiplication, we divide, giving us h is equal to 13 tan 3.5 degrees divided by 1 minus tan 3.5 over tan 9. And taking out your calculators and plugging in, make sure your calculator is in degree mode, we get our approximate height. H is approximately 1.29 miles high. All right, some good word problems there involving our right triangle trigonometry.